Great. So let's get started. So before we get into what cloud total cost of ownership is, how do you reduce it? Let's take a look at how different deployment models have evolved over the years. So in the graph that you see here, you see a decreasing stack implementation on the bottom and increasing business logic focus on the y-axis. So we started with something called bare metal, which meant physically managing and configuring servers. These were co-located. You had to spend on infrastructure. You had to spend on maintaining these servers, both from a software point of view and from a hardware point of view. Moved over to virtual machines, which were resource optimized bare metal, yet you were living with something called idle times. Idle time, to define it, would probably be the time that your server or your compute capacity is not being utilized to the maximum, that you have certain times when you're not running to the full capacity that you provisioned for. Moved over to containers, which was another interesting concept, which packaged code and all the dependencies that came with it into a single container, and these could be deployed on any infrastructure. And to where we are at, which is serverless, which essentially abstracts all underlying infrastructure and decisions from the developer and lets you focus more on your core business logic or developing your core application. Since Catalyst is serverless, and that will feature a significant part of our discussion for the audience that is not aware of serverless, what serverless aims to do is it aims to abstract all kinds of infrastructure decisions and server management activities away from developers. The applications are developed without you having to worry about either scaling, tweaking, or implementing a server. Resource allocation is something which is managed by the cloud provider. So all of these get offered to you as a managed service. Now, when we look at serverless platforms, platforms are mainly constituted of two large components. There is FaaS, or functions as a service, and BaaS, which is backend as a service. What functions as a service gives you is computational muscle on the go, where you package your code into a little more than the code itself into a function, which can then be execute a certain workflow or execute a certain functionality once it is triggered. Backend as a service provides pre-written software for activities that happen on servers. Most generally, we're talking about database management, we're talking about a managed file store, we're talking about activities that involve hosting, storage, user authentication, push notifications, and many more features. Now, if we are to go into a very basic evaluation and understanding of how things would operate differently in a server versus a serverless scenario, a server would require you to first set up a server, load the code onto that server, and then finally execute that code. Now, between setting up and loading the code also would be a certain amount of activities that would exist. And similarly, once you load the code and you have to execute it, there would be certain specifics about the server that you would have to manage. Whereas if you look at it from a serverless point of view, you just hand your code to the platform and specify configuration, and you're ready to go. So essentially, what you're doing in a server full instance is you're running a virtual machine, you're configuring it, probably loading an OS into it. Post that, you load the application onto the virtual machine, and then you're required to scale up, down, or horizontally, entirely depending on what kind of usage your application is generating. But in a serverless platform, everything that pertains to all the activities that we just mentioned, which is running a virtual machine, configuring it, managing the OS, managing logging, monitoring, scale ups and downs, creating redundancies, are things that are pre-managed and that are given to you as a value-added service at a serverless platform. Now, there are different factors that require a lot of different developer attention when you look at it from a serverful versus a serverless point of view. There are multiple aspects that you have to keep in mind when you're getting a server. You need to know the size of the VMs. You need to know what CPU it's running, the RAM, what kind of network are you on. You need to know about your OS and OS config, and that's something that you need to manage. The application code itself, again, and the application package installation. Whereas in a serverless platform, you want to configure the size of the function in terms of the memory and the timeout, and put in the application code. So that reduces the effort a significantly longer way in terms of how you were to manage your application on a serverless platform in comparison to a server. Now, cutting right through to the main topic of the day, which is how do you reduce your TCO or your total cost of ownership? So the total cost of ownership will comprise of the initial price, usage, and maintenance of both your physical and your cloud resources. So we're talking about a system which is running on, or an application which is running both on-prem and on cloud, truly in the server full space. So we will be touching upon how the serverless platform would impact your total cost of ownership. But it's important to see that if you are running something which is a mix of on-prem and on the cloud, what are the steps that you can take in order to reduce your TCO? Or these are roughly called the 7 commandments of reducing TCO. So to start off with, you need to be able to support workload portability. So you need to identify market needs that are going to gain momentum and going to form a considerable part of what your application usage is going to be. And you need to select the ones that are flexible in terms of how you can scale up or scale down, or how you can add multiple components, or generally the flexibility in terms of a pricing standpoint that would come as part of this particular tool, for it to be, for it to make sense for you at a later date, and for it to have that kind of longevity. The second step would be to focus on network solutions that produce maximum agility. So from an agility standpoint, you want to make sure that the money that you're spending is more agile and is giving you returns that, or is giving you a service in return, which can spread through multiple use cases, which is future looking, and which will solve a larger problem for you in the long term. So you need to figure out what existing investments of yours will help in minimizing future costs. You need to hold on to investments that have a positive impact on your growth specifically, because the larger you grow, the greater your profitability becomes. And that's where you need to focus on solutions that give you maximum agility. Again, using a cloud governance tool is something which is extremely important. You need to have a cloud billing tool that supports a wide set of use cases, so that it's able to tell you, or it's able to estimate for you, where is it that your spend is going and where is it that can be optimized. So it needs to be able to track both cost and help prevent waste for you. Preventing waste in this case would be that it helps you in figuring out if there are any circular workflows that are being created, or if there is a particular service that can use a lesser amount of resources. In addition to helping you tracking your cost and preventing waste, you also need your cloud governance tool to help you in predicting costs. So that's where the most interesting part will come in, that if you are able to predict your cloud costs, you'll be able to optimize your workflows in a way that you can then look to reduce them from the level that you're at. Optimizing your cloud storage. Now, it's very imperative whenever you're doing some heavy data operations, or if you're running an application that has a lot of data input and output involved, that you optimize your cloud storage both between physical hard disks and flash to improve the storage and the control that you have over data. You need to be able to control data coming in from different sources and have them segregated enough so that you can look at them in separate ways and figure out if there is a certain aspect of data, or a certain source of data that you want to reduce, and you want to redirect that very cloud storage to another service that is probably giving you a different stream of data. Automation. So automation features of cost optimization tools are something that would be extremely beneficial in reducing your total cost of ownership. You can set up events to detect misconfigurations and these automation tools will help you trigger those certain workflows, which will help you in capturing whenever there is a spike in terms of usage that's going to happen because of a simple workflow, and raise the flag to you at the right time so that you can go ahead and fix it. Automation should also be configured in a way and chosen in a way that it helps you in figuring out how do you minimize your future costs. Automation in turn would also help you in a way that it will reduce your costs from a manpower standpoint, because if you have certain automation flows in place, it will mean for reduced amount of time being spent by developers to figure out what needs to be fixed and on what priority. The sixth is essentially reducing your on-prem utilization and moving to the cloud. That would mean that you move more of your resources onto the cloud. The advantages are manifold. Not only would you get access to innovative automation technology that exists for cloud native development, but a lot of other frameworks that could help reduce your time to go live. It frees up your physical IT team to start to focus on more important aspects or more revenue generating aspects that could come as a part of that freed up bandwidth. The seventh would be to have cloud backup and disaster recovery tools. This is essentially so that you can manage your critical data at a backup level. You could figure out and configure the right tools so that your data is backed up, utilize simplistic solutions that offer a cost advantage, and also employ disaster recovery tools that can help you in optimizing your storage, in protecting your data and managing it better overall. Now, these are 7 extremely generic ways which would apply to a very host different types of use cases that could employ all of these 7 steps. The 8th step, which does not figure into a lot of presentations or a lot of documents or a lot of content that you'd see online, is exploring serverless. Now, we've seen how we can reduce total cost of ownership in a server full instance. Let's take a look at the kind of factors that would make up a TCO when you're talking about comparing a server full solution with a serverless solution. So there are different types of costs that would be involved in making up the TCO. You would have the cost of infrastructure, or what is the cost of my servers and components that I'm utilizing. The cost to build, which is essentially how much do I need to pay a developer build a project. The cost to maintain, then how much do I need to spend on maintaining and supporting my architecture and maintaining and supporting my code. And the fourth would be the opportunity cost. That's something which is often left out, but given that you would do the activities in 2 separate ways, there would be a time differential that would be there. What would you have done in that time differential that exists, which could add value to you? So let's take a look at all of these costs one by one. So let's look at the cost of infrastructure. So here what we're looking at is primarily the cost of servers or the computing infrastructure, or you're comparing it with a serverless platform, which is essentially what is the kind of usage fee that you're getting. Now let's take a look at the server full versus serverless comparison from cost of infrastructure at 2 different cases. So in case 1, what we're saying is that you have a particular application that's running simultaneously at full load 24/7. So there is no idle time, so to speak, in this case, in a server full instance. So if your server is what this means is that your application is running at 100% load to your server. You've not provisioned anything beyond that, not provisioned anything below that. The outcome in this case would be that since you're utilizing your server for your 100% capacity, serverless in this case would be significantly more expensive to run, given that you run the same kind of a load on your application on both these platforms. Another case that needs to be looked at from a constant usage point of view is that what if we try and match up the cost per month to run an application and say that, okay, if I were to spend $100 on servers, and if I were to spend the same $100 on serverless, what kind of a difference would it make to me in terms of my computing requirements? Now, while your price of usage may be matched up to the same, the computation capacity that you will get in a server full instance would be much more than what you would get in a serverless instance. Now, why that happens is that if you were to simply divide your usage that you generate on your server and do a unitary method calculation to come out at a sample number of invocations, the number of invocations you would get in a serverless instance as compared to a server full instance would be drastically different. The serverless would offer you significantly lesser amount of computational capacity as compared to a server full instance. Now, why does that happen? That's extremely important to understand. All of this happens because of the value-added services that come as part of a serverless platform, which make it more expensive. So we've seen that, if we were to do comparison at 100% load, it wouldn't make a lot of sense. But here's where things get interesting. On my left, on the left of the slide is where you see this particular graph, which is indicative of any consumer-facing app usage that you would look at. Ideally, it would start off from the day. People would be sleeping at this time. You'd see maximum load, minimum load at a time when people are generally sleeping, and once they start to wake up, usage starts to go up. It peaks once in between, then goes down again because people are in transit or spending their evenings, and then goes up slightly close to bedtime when it starts to decrease throughout the night. So, if we were to now do that comparison, it's interesting to look at it from an idle time point of view. Now, if I were to just look at this same graph and color it two different ways, you'd see the yellow color and you'd see the orange color. Now, the graph of usage is what we see over here, and this particular head of the graph is essentially what the architect or the developer would have provisioned the entire server for. So even if you're not using it, if you're on a server, you're paying for the orange lines and the yellow lines, both. And if we were to take out the area under the graph, which is the yellow lines, which is essentially what utilization you're generating, utilization would generally vary from 50 to 60%. However, any architect or any developer of worth their salt would always keep a buffer in place and provision for a larger amount with a safety margin. Because if anything were to breach this 20 line over here in terms of usage, had this not been provisioned, this particular people lying over here would get loss of service. So anybody would probably provision an upside of 30% when they're looking at knowing a constant usage that they expect. What this does to overall utilization is that it reduces the 50 to 60% utilization that we were seeing to a 38 to a 45%. So effectively, you're using only 38 to 45% of the capacity that you're paying for. The interesting thing happens is that you are on a flat monthly subscription fee. So you have to pay that come what may, irrespective of the kind of usage that you're getting. The minute that you start to think in terms of creating redundancy, which is essentially employing an altogether new server to match it to form a backup, the utilization that you were seeing at 38 and 45 would go down by a factor of 2, which would essentially mean that you're running between 19 and 22.5% utilization on an average. Now, 19 to 22.5% utilization isn't really the wisest use of your resources in terms of the kind of cloud costs that you'd be able to rack up. Whereas if you look at it from a serverless standpoint, you'd generally pay only for the yellow shaded part, which is you do not have idle times. You do not have to over provision that extra 30% because there is auto scale up and scale down that is baked in. And you would not have to create an alternate server because redundancy is also baked in. So you pay as you go, you do not have idle times, you have the ability to scale up and down and have redundancy. and save on cost, especially when you are not running an application which is running on constant load for the entire day. Let's look at the second element that we had in cost, which is cost to develop. Now, developer time, I mean, in the first slide, we saw that, as stack implementation is decreasing, focus on business logic is increasing. So I think we fairly established that the best use of a developer's time would be to work on their core application and the core functionality that it has to offer. Now, we're looking at serverful instances in comparison to a serverless instance. So activities that involve redundancy, auto scaling, load balancing, monitoring, having a failover process, and deployment would all be dependent on the developer. What this would mean is that there is more time being spent on these activities, because what we're talking right now about is development activities. All of these would be handled in a serverless platform by the cloud service provider. So what we're looking at is that if you were to have your existing developers do all of these activities, that would mean at least a 10% to a 30% extra time requirement at their end for the development activities. We're not talking about the maintenance. And it's also fair to assume that these activities would not happen throughout the length of the project. So as a fair assumption, what we've done is that we've taken that, these activities would be required only for half the time of the project, which would essentially mean that you're increasing your wage cost by 5 to 15%. This is the extra effort that your developer would have to put in to deploy all of these things. Now, it could either be the same developer, or it could mean that you hire more developers to do these particular activities that would ideally be handled by a serverless platform. So 5 to 15% in extra wage cost and 10 to 30% in extra time is the number that I want to leave you on this slide with. Third cost that we'd spoken of in the introductory slide for this session was around a cost to maintain. So a cost to maintain would be a combination of the extra effort that you'd want to put in for maintenance and the resource requirement. So the activities generally associated with management would involve, the configuration or reconfiguration, software management, which is essentially installing patches if there are any, or updates, the monitoring, scaling, and backup and recovery. Now, with these particular activities, we could figure out two different costs that would be associated. You would have a license cost in case there is any new software update that you need to install, or if there is any new software package installation that is required, which has a license involved. The second cost would be the manpower cost. So as we saw that, there would be a 10 to 30% increase in time required for the development of all the efforts from a server management perspective. We estimate that 1 day a month in a 20-day working month would on an average be spent in maintenance activities. So if you were to have the same developer do it, that particular developer would spend at least 1 day in a month, which would mean 5% in extra wage cost and 5% similar to it in time cost. So in these two costs, which is cost to develop and maintain, we've established that we're looking at an additional cost that's coming in of about 15 to 35% in terms of your wages, in terms of the time cost, and 10 to 20% in terms of extra wage cost. Now, the fourth cost head that we've spoken of in the beginning was the opportunity cost. Now, the time that your developers are spending on server management is time that could have been utilized for other activities. So we saw that in development, the extra time consumed per activity would be about 10 to 30%. In maintenance, we estimated it to be about 5%, which gives us a total time opportunity of 15 to 35% per developer. The total man-hour opportunity in this case, translating to 8 hours a day and 20 days a month, would be about 24 to 56 man-hours per developer hired for each month. and about 7 to 16 weeks per developer hired for the year. Now, assuming that you're deploying a new feature in about 3 to 4 weeks, this would mean that you could launch up to 2 to 4 new features within your application, instead of having your developers focus on the development and maintenance costs associated with a server. Now, these 2 to 4 new features that we're talking about could generate significant amount of revenue upside or growth for your particular application, thereby leading to a greater amount in profitability. So where does Catalyst fit in? So we've been talking about how serverless platforms are beneficial, how they can take your cost down. So quickly recapping, we have compute, we have storage, we have AI services, and monitoring and other ancillary services that come as a part of an entire platform. Now, interesting to see that all of these functionalities, be it the compute functionality, the cache, the orchestration, logging, relational database, all of them come in a truly serverless format at Catalyst. By that, I mean that you pay only for what you use, and you are not charged a fixed monthly. Whereas if you look at competition, there are certain elements within competition that do come as server-based or a fixed monthly usage. How do we, to answer your question, I think this was by Ankit, that how do we offer a lower total cost of ownership? So at Catalyst, we offer a free, fully featured sandbox, and you're able to test out your application because there is zero cost till deployment. Now, we do not limit any features, or we do not offer a limited tier sandbox, which essentially means that we plug out the functionality for you beyond a certain amount in usage, or we'd require you to give up certain credit card details on sign up so that we know that if you exceed a certain point, there is an opportunity to charge. We're completely transparent that way. You get to test out all the functionalities. Till the time that you move to production, we do not require any credit card details from you on sign up. Once you move to deployment is where we offer at least 10 times more the number of free invocations that competition has to offer. Competition will probably also offer you these free invocations in a throttled manner, so you'll be able to utilize 1 million each month, and then that sums up to about 12 million for the year, whereas we do not have any such conditions in the free invocations that we offer. Why would you choose Catalyst? You choose Catalyst because we offer a free, fully functional sandbox. We offer decoupled environments. We have a host of pre-built microservices and advanced AI operations readily available as APIs that you can utilize and reduce your time to go live. We have an extremely transparent and uncomplicated pricing. And one of the questions that we often get is around the fact that you're a new platform. How is it that we can establish that trust factor with you? You own, the tech stack in terms of the core code, and your core code and application is running on Zoho's infrastructure. So the cloud that Catalyst by Zoho operates on is Zoho's proprietary cloud. That is the cloud that powers all our other applications that have millions of users worldwide. So that adds the extra trust factor to in terms of you being comfortable with the kind of terms of service and the availability that you get from a platform like Catalyst. That brings us to the end of the presentation for today. You could reach out to the names mentioned on screen, the emails mentioned on screen, in case you have any further queries. Should you be interested in looking at a price comparison document, I'd request you to just leave us a line on solutions@zohocatalyst.com, and we will get back to you with a price comparison document that you could utilize to understand where your cloud costs are and where can they go for certain specific use cases.